Alright, so what we do here, we tend to expand the brackets. We do that by expanding the bracket, and you just want to do that saying x minus the mu and the other x minus the mu. Right, that's, you go with your square and look at this, right? And then the probability distribution of x, you just want to tag that along at the end of that variable. I could make that, change the color to be black. And now that we have that, we want to flip the bracket open, and we get with x squared minus x to the mu minus another x to the mu. Then we want to get plus the mu square. Okay, so we want to close the bracket and probability distribution of x, and then we get here, we have to simplify things up. Right, and then what we do here is we need now to use the probability distribution to kind of open the bracket all up, and that's what I'm going to do. And of course we will get the x squared multiplied by the probability distribution, then minus the very much 2x the mu, and then we're doing that together with the probability distribution of x, then plus the mu square, and we're doing that possibly with the probability distribution of x. So we're going to close the bracket, and then from here we can group the sum. For instance, you tell me I should sum up, let's do this way. You ask me to sum up 3 plus 2. Okay, 3 plus 2. I can say, okay, summation 3 plus summation 2. That's okay. So I'm summing 3 and 2. So I could sum up them in groups, right? I just want to break that out. That didn't really make sense, but that is exactly what it would mean if I kind of put it in a very simpler way. So I'm going to have to group the summation. So we group the summation, and if we do this, we'll get the x squared by this summation, then minus, we group that summation, and that will be 2x to this mu, and we put it together with this, and then we go with the next one, which will be the summation, and that will be the mu square, and we're multiplying that by the probability distribution. Now we'll take this and work on this one after the other. We have to work on this one after the other, and to do this I'm going to have to first work on this individually. Okay, but before we work on this, if you look at the right hand corner of the screen right here, you will notice I put in the mu, or the expected value, equal to x multiplied by probability distribution of x. Did you remember this? If you did not remember this, I'd like you to watch the previous video, and please, I should say this right now, please do not forget to share, subscribe, and also like this video. By liking this video, you are also going to be increasing the chances of this video to get to other people that this video might also actually help. So please kindly share, subscribe, and click on the notification bell so that you can get a pop-up each time I post a new video. All right, let's get back to this. Now in this I will get back straight here. Right now, if you check vividly here, you will notice some expressions here are found here, but in case you didn't see it, I'll find them for you. Let's make it as simple. In that way, that would be here on square, right, and the probability distribution of x minus, making this simple, and I'm going to rearrange what you get here. So we have that. I'm going to take the 2, which is still there. Now I'm going to take mu. That is like 2 times x times mu is the same as 2 times mu times x. So we're taking the mu. Now I'm going to put the x. Then, of course, probability distribution of x. Now, if you check the right hand side of the screen, all of this should make some sense now. Mu square by the probability distribution of x. This is making some sense right now. Okay, so here, what do we do? What do I do? See here, did you see this? That is mu, or expected value. So I'm just going to put mu because it's kind of easy for me to write mu. So I'm going to put mu. So in that way, we want to know that this all square with the probability distribution of x, and I'm getting this here of 2 mu multiplied by an extra mu. Did you see that now? So plus straight away, summation of what now? Mu square, or should change the color, by the mu square and the probability distribution of x. This is getting interesting. Okay, so we want to take this all square. We're taking this stepwisely. Okay, so guys, we are not trying to rush up things here. Okay, so you guys can definitely follow up as I'm doing this, which is highly intuitive. So what you get here is going to be 2 mu square. Do you agree with that? And then plus we get this straight away with mu, summation of mu square, which I should have done with the other color. So summation of mu square, and of course probability distribution of x. There we go. Now I'm going to move this off the scale, and now I will deal with these two guys. Okay, so I'm going to deal with these two guys. Sorry about that sometimes. So I'm going to be dealing with those two guys. Okay, in that part there, you will notice that mu square seems common, right? Mu square is definitely common, right? So I'm going to just have to look at this like mu square. Mu square is definitely common. So it's more or less like you're saying the summation of the mu square. So mu square is common, very much common, as you can see from this part of the video, right? So if you know what this will be, well, you can go ahead and try to figure it out. If you're not, you can follow the video to the end. So let's try to do something here. So what we do is to take the summation of x squared. This is now simple to break down. Summation of x. Okay, so I'm going to get rid of these guys here, and what do I do now? Mu square is common, so I'm going to say minus, okay, mu square, which is definitely common. All right, so since mu square is common, we'll be left with summation of 2, right? Summation 2. Okay, so plus, and in this guy, mu square is also common, right? Did you see that? And we'll be left with summation of that. Now, in this variable of this contest, right? In the variable of this contest, what is summation of probability distribution? What is the summation of a probability distribution? Did you remember what the summation of probability distribution is? This guy, what is it? It is 1. When you sum up the entire probability, it's going to give you 1. So this guy should be 1, right? So that's 1. What is the summation of 2? Summation of 2 is what? 2. So it's also 2. So we will come up